can identify that, yeah, this graph has symmetry over the origin. What I have over here, and the opposite is going to be over here. So we have a positive, then we have, plugging the negative, everything's going to be negative. It has symmetry over the origin. You can also see that when I plugged in like 1, I got 2.4495. When I plug in negative 1, I got the same value, but it's opposite. That is what we mean by symmetry of the origin in odd functions. Is that when you plug in the opposite, you get the opposite output out, unlike even functions. All right, so that is how we can determine odd and even functions. Now, sometimes what we have are what are called neither functions, okay? Neither odd nor even. Well, neither odd nor even means that, well, we neither have symmetry over the origin or we have no symmetry over the y-axis. Well, how can we identify this? Well, let's check this out. We go through the same procedure. We plug in negative x, all right? And we identify if it stays the same or if all the terms turn to opposite. So when I plug in this negative x squared, all right, into this one, what you may notice is that, well, this first term changes to x squared, all right? So it stays the same as the original. However, when you take and plug in this one actually turns into positive 5x, which actually is the opposite of the original. So it stays the same, but this one changes. All right? So this one looks like even, this one is odd, and this one, the term, well, 2 stays the same, so that would be like an even function. Well, we got even, odd, even. They aren't all the same. They aren't all the opposite. So what we have here is a neither function. It is neither odd nor even. And that occurs actually more than probably odd and even functions. You can identify this because it has no symmetry. No symmetry over the y, no symmetry over the origin. There's nothing. All right? No symmetry. There also, you can see by the graph that if I plugged in 1, I get negative 2, but if I plugged in negative 1, I get 8. These values do not match up. All right? They're not the opposite or they're not the same. Therefore, we can identify that there is no symmetry, and therefore it is neither an odd nor even function. The same thing can be had over here. If I take and I plug in negative x into here, I get out negative x. All right? Well, that's very similar because this is the opposite of what our original value is. However, when I plug in the square root, I actually get a negative x minus 1. Well, this value changes, all right, to be, well, opposite, but the negative 1 changed to be even, and therefore it's not the same inside, so we'll have different outputs. Now, if that confuses you, and sometimes it can, because this algebra is a little confusing, sometimes it's good to just look on a graph. And from this graph, if you would graph it, you can identify that right here, this graph of the function w of x does not have any symmetry. There is no symmetry. Because it has no symmetry, it is a neither function. You can also identify it from its table. I plug in 2, I get out an error. I plug in plug in 1, I get out 0. I plug in negative 1, I get an error. These values do not match up. All right, they're not the opposite, and their outputs are not the same. Therefore, this is a neither function. And finally, let's try this. X cubed plus 1 over x. When you have a function like this, if I plugged in, negative x in there, we have t, we plug in negative x. We have negative x cubed plus 1 over negative x. Well, with a fraction, fractions are opposite if the top is either positive and the bottom is negative, or if the top is negative and the bottom is positive. That's when a fraction changes to the opposite. So in here, what we're looking for, does this everything change to the opposite? Okay, or does it stay the same? Well, when we look at this, we notice that the top, all right, or the numerator, just changes to negative x cubed, which is the opposite of what the original function was. However, plus 1 stays the same. So right there, I have an opposite and a remain the same or like an even function characteristic. Therefore, I'm guessing this is probably neither. The bottom does change the opposite. However, we have opposite stays the same, changes. This is not either all positive or negative or positive. Therefore, this is a neither function. Once again, if that confuses you, look at the graph. The graph, you can see there is no symmetry. No symmetry over the origin and no symmetry over the y-axis. Therefore, we can see that this is not an even or odd function. The same thing can be looked at by the table. Plug in a 1, I get out a 2. Plug in a negative 1, I get out a 0. Those values don't match up. Therefore, it doesn't have any characteristics of odd or even functions. Well, I hope this mini lesson has helped you identify what odd and even functions are, okay, and how you can identify them both algebraically, numerically, and graphically. You should be able to do all of these, all right, and hopefully this will help you out identify, all right, how to identify them and be able to finish up this homework assignment. So good luck, God bless, and just for all those that are watching this, the word of the day is Tabasco. Tabasco. Yes, Tabasco sauce. All right. Have a great day and enjoy.